All right, welcome to session 13. I think this is the seventh week of this program. So we are gradually getting towards the end of the second month of the program and gradually getting towards the end of the program itself. So kudos to you for sticking this long. It has actually not been easy. I can see the challenges that most of us are having, and despite that, we are still coming through, right? So that is why whenever I see some excuses, it's not fair because a lot of persons here are also having the same thing going on, but they still try as much as they can to meet up with deadlines. So you don't expect me to just be giving that allowance all the time, all right? So it's not easy for anybody at all. It isn't easy for anybody. So if you miss the deadline for the previous assignment, just have to try not to allow that happen again. All right. So for today, we're going to actually we're moving to another phase, right? So I told us we have three phases in this program. We have the first one, which is an introductory concept, right? For on Python, introduction to Python generally. So I introduced us to Python concepts, data types, variables, and all of that. And then we moved on to libraries and we started using libraries. That is the second phase where we introduce libraries like NumPy, Pandas, and Matplotlib, right? So that is basically data analysis, right? We basically learned how to use Python for data analysis. Now we're going to be entering the last phase of this program, which is machine learning. So it's just like increasing gear, all right? The first phase was in a lower gear, so things were going smoothly, everybody was happy and all of that. Second phase, we entered the second phase, it became the difficulty level increased a bit, all right, but I believe by now, if you've been following, it should not be a problem for you. Now we are now moving on to the last phase, which is machine learning. So this one is actually going to be very interesting, right? We that is what separates data scientists from data analysts. So we're going to be looking at machine learning, but for today's class, I'll be introducing us to machine learning. So it's not going to be a long class, it's not going to be a lengthy class, it's just going to be a conceptual class where I give you an idea and help you build intuition on what machine learning is. So moving forward in from tomorrow's class, why when we start looking at machine learning details and all the things that pertains to it, it will not be strange to you. All right. So, but we are going to look at that, right? In today's class. But before we do that, there are two things we're going to do. We're going to first go over the assignment, right? We're going to go over the assignment and do the correction, and also we are going to do a kind of brief revision, all right? So I want us to revise on what we've done so far. So like kind of recapping session phase two of this program. So that is what is going to be happening today. Today's class is going to be interesting, and I actually won't it won't be very long as I will try as much as I can to end it on time because what we have today is actually not lengthy. We're not going to be doing anything technical today. It's just going to be a conceptual class, right? So yeah, that is it basically. So before we start, I want to know how many of us attended Variety Night yesterday? Variety Friday rather. How many of us attended Variety Friday? Just respond in the chat. Okay. All right. So I expected a lot of us to attend, right? How was it? Like, how was the session? Like, hope you were able to learn one or two from the session, and you gained a lot from it. All right, all right. Yeah, I think a lot of us attended. I didn't really see everybody. I wasn't able to see the participants, but I believe A lot of us from data science attended the class, right? So we talked about networking and how important it is in career growth. So I've said this that Variety Friday is part of this program. Attendance is taken and a mark is attributed to the attendance. So if you missed, you just know you missed some marks, all right? This is part of building you, right? We are doing the variety night is going to teach you things that you need to know, like on the other side, right? While the classes is going to teach you the core skills. So bringing this thing to two together, you are going to come out from this program fully baked, not half baked. All right, not half baked. So I just hope you're able to put into practice what you learned from yesterday's session. For those of us that didn't attend for one reason or another, I understand that some of us might not be chanced, which is very fine. The class, the recording is up on YouTube already, so you can as well just go to the YouTube channel. I think the link was posted on the general group, right? So you can just go there and it's a 1 hour session, so it's not long. You can watch it and trust me, you're going to definitely learn one or two from it. So please try as much as you can to not miss the subsequent variety nights, Friday rather. I don't know why I keep saying night. Is not You are not going to regret spending that time there. Trust me, you are definitely not going to regret it. All right. So that's it for that. Now let's move on. Let's move on. All right. So I'm going to be sharing my screen now. All right. So I'm going to quickly do the correction for the assignment, the week's assignment. So this week's assignment is quite different. There are a lot of things to do here. They are basically doing data analysis in this assignment, right? So one good thing about all these assignments is that once you're able to follow through with this assignment step by step, the final project won't be a problem for you. Like you won't have any challenge while doing the final project, because at the end of this program you're going to be given a final project, right? So if you're able to go through all the assignments I've been given till the end, the final project would be a breeze for you. To be a breeze, you won't have much headache. So that is why you need to be consistent with this assignment. All right, so let's just go over what we have here. So this is the week 6 assignment. You were provided a data set for this particular assignment, which is the retail transaction data set. All right. And so, by the way, the class rep reminded me of something that I've not posted the NumPy cheat sheet, which I just did before this class. So I think you should be able to see that. I posted two of them, so you can open it and just look at how the functions the functions and the common methods that are used in NumPy. So we already have the Panda zone. I also post the Matplotlib cheat sheet today. If I don't post it today, please class rep remind me again. All right, so I'll do that. All these things are resources that would help you learn. So let's go back to the assignment. So we have 10 questions here based on this the data set that was given. So you are asked to do a lot of things here. So we're going to go over them one after the other. So the first thing to do always in any data science or data analytics project is to import the libraries you'll be using, and that import should be at the beginning of your notebook, all right, as it is now. So anybody that is reading your notebook will see the libraries you're using and know that, okay, these are the things that we are going to be using throughout the course of your code or your project, all right? So here you can see we import matplotlib. Okay, a quick shout out to Favor Odinia. Sorry if I didn't pronounce that correctly. If you are here, you did well in your assignment, so that's why I have it here up um on the screen. So I haven't actually graded everything, but I like this particular assignment. So kudos to you and well done. So basically, you import your libraries, all right? And there are some instructions I gave at the beginning, which is very important to note. So this is the normal instruction that you've always been saying in the assignments. Now, this also is another common one. Now, the last two instructions here is give titles to all your charts and give X and Y labels where necessary. So I just need you to annotate your chart so that while I'm looking at it, I understand what exactly it is you're doing. All right. So you need to give title to your charts and also label your Y and X axis where necessary, right? Because sometimes you don't actually need to label your X axis because if you have, let's say, days of the week in your X axis, there's no need to label it again days of the week because seeing it, someone already know that okay, these are days of the week, right? So the labeling is to kind of explain what is on the X axis or the Y axis, all right? So the second, the last instruction here is use the ggplot style for your chart. Now, I think some persons miss this. There's few assignment I saw. Some didn't do this. All right. I showed us how to do it in the last class. I needed you to use ggplot. So if you come here, you see that this Favor did it here. So use ggplot. I showed us how to check for the available styles in matplotlib, and you can just pick the one you need. But in this particular assignment case, we need to use the ggplot, so we just have to use this particular syntax. All right, there's a typo, load, not load. So the first question now, so basically you have to load your data sets, right? Use your PD, read CSV, and all of this. Question one, get now some persons did this assignment, but they did not put the questions. I don't know how you expect me to be going over to be grading a lot of assignments, right? Every week I get over 100 submissions, so there's a lot of assignments to be graded. So making things easier for me doing there's some certain things that you do that makes it very difficult for me to grade your assignment. So and you don't want that, all right? So some person didn't even include the question before the answer. They just did the answers like that. Just so I don't understand how you want me to be able to calm down and start looking to understand which question or which answer is for which question. No, no. So you have to do it like this. You have to write out the question first and then the answer in your code. All right. So the first question is get the number of records and variables contained in the data set and convert everything to lowercase. So we all know this. So getting the number of records is using df.shape. All right. Converting columns to lowercase is by using this syntax. All right. And now you can see how this person beautifully used string formatting to illustrate or tell us how many rows we have and how many variables. So we have 1,167 records. Record, rows, observation, those three are the same thing. You can use them. You can use them. You can use them in the same context. All right. You can use them in similar context. So you can say records is fine. You can say rows is okay. You can say observations is also okay. So number of records are 1,167. All right. Okay. Jack. It seems like you don't give up. All right. Just meet me after this class. I would look at your this thing. All right. So you would finally leave me alone. All right. So just send me another DM after the class. So the df.head would basically just show you the first 5 rows and all of that. So you can see we've converted all the columns here to lowercase. So that is the first question. Very simple, very straightforward. No much complexity. So the second question is there any null value or duplicate record present? So you now have to investigate. You need to start investigating your data set to know if there are I think there were two persons that were making a plea. So the second person should also send me a message as well. So the null value used is null. So basically, you already know the functions for to compute all these things already. So the duplicated, you know the function for it. The null value, you know the function. So you can print them out, and you can see here that we have quite some variables with null values, right? So you'd see how you can treat them. All right, so number of duplicated records, there are just two of them. So you need to drop the null value, as I said here in question three. I like how this person, after writing the code, came here to explain what was happening. So these are good practices. Trust me, they are good practices. So question three: what is the new shape of data frame after dropping? So after you dropped your null values and duplicates, which you can use this code, using this code. There's a particular assignment I saw that use this particular syntax without assigning the result to your data frame. So you are not going to be affecting or making any change to your data frame if you do it that way. If you're not using in place or reassigning it to your data frame, you are just doing it in isolation, right? So if you print out your data frame again, you are going to get the same thing that you had when you didn't drop or before dropping your null and duplicate. So you can see after dropping it, you can see the shape here 1137. So some rows have been dropped. We still have 8 columns, all right? That's question three. So question four is create a new data frame containing just the numerical variables and assess the relationship between variables. So you can see the person got the D type first, and using the select D type function and this particular parameter, we can select the particular data type or the columns that's the columns, specific columns, right? Based on the data type you want, and assign it to a new data frame. So if you see here, this is a data frame with just the numerical variables, and I asked you to assess what the relationship between the variables. So these are generic question. I'm not telling you what to do specifically. I'm not telling you to do correlation. So once you hear relationship, you should already know that okay, he's trying to ask us for the what can we use to assess relationship. You can use correlation analysis, all right? So I actually this assignment will help you to think, to help you to approach questions, right? And all of that. So these are the things that you'll be seeing when you're working. So how we do that is by using the core function. So you can do all of this and as well use our Seaborn library to plot the heat map. So whenever you are plot and getting correlation, it's always advisable that you use your heat map. All right. So your heat map is basically going to map the correlation value between variables in your data set. So you can see here that each of these square or rectangle here corresponds to a particular correlation value. So this negative sign here, the negative sign here signifies negative correlation, while the positive sign signifies positive correlation. But I don't think there's a strong correlation, either positive or negative, in this particular variable, between these variables. So anytime you plot correlation matrix, this is called a correlation matrix, you would realize that you notice that the diagonal aspect always have values that are equal to 1. Can someone just tell me why? Just quick one. Why do you think this happens? Like, why is the diagonal of your correlation matrix always equal to 1? Okay. All right, same variable, same values. This is because x over x equals to 1. The relationship is constant. X and y are the same thing. The value, exactly, right? So basically, why we have this value is because we are getting the assessing the correlation between that value and itself. So the correlation between a value and itself, a variable against itself, it should be one because it is perfectly the same thing, right? If you put them side by side, you see that the numbers are the same thing. So that's why we have one. So if you trace it, this particular box here corresponds to the y-axis, you see customer axis. And if you draw it down to the x-axis, you still see customer ID, all right? Come to the second box here. If you draw it to the y-axis, you see quantity. And if you draw it to the x-axis, you see quantity. So basically, what you are seeing here is quantity. The correlation between quantity and quantity is what? One. Correlation between customer ID and customer ID is one. Correlation between price here and price here is one. Correlation, so is this is why we have this diagonal one value. So if it depends, no matter how big your correlation matrix is, diagonally everything will be one, right? Everything will be one. So that is it. Let's just move forward. So I actually like how this person still explains the output here. That is very nice. So what was the question again? Create a new data frame and assess relationship. Okay. So we've done that already. All right, we've done that. Okay, customer ID is not supposed to be here. Yeah, actually. So I think this person removed it in this new correlation matrix. Okay, that's nice. Okay, so wow, this is very very nice. This is very nice. So question five, you have a transaction date variable. Convert it um to a date time variable and extract. Adebayo, please, can you scroll up a bit to see the heat map? Which this particular one. So we don't really have time. So just this is what we have here. So this heat map is has three variables. Why this one here has four variables? All right. So one, the customer ID was dropped here. So that's why we have three variables here. All right. So question five. So now I needed you to convert the date variable into an appropriate date time data type. All right. So we use pd.date to date time to do that, and then we can extract. I asked you to extract the month names and the day names into two new columns. So that is what we have here. All right. Now question six: check for outliers. Outlier in the price column and remove any value that's greater than 300. So I already give you an hint here. I don't even know if I gave you a hint, but anyways, you know how to do that. You can use n largest to get the n largest and cut it from a particular place, all right? So you can see now there's something that this person did that is nice. Using box plots, I don't know if favor is a boy, is a male or female. Right? I don't know what pronouns to use, but favor plotted the box plot before removing the outlier. And you can see how the outlier is affecting the box plot. So all these values that are here, they are extreme values. So you need to remove them, all right, so that you get an appropriate data distribution. So this is before the removal of the outlier, and this is after removing the outlier. You can see that your box plot is now more pronounced. You can now see a distribution of your of the values in your in that particular price variable, right? So this is how you can work with um so you can work with box plots to deal with outliers, all right? You can as well use um histogram as well, and also scatter plots too. So Yeah, question 7. Plot a scatter graph to assess the relationship between price and discount and give the graph a title and make the color green. So I'm just giving specific, I'm just making giving you specific instructions here because I need you to kind of just touch your graph a little. So that's straightforward. You can just use Seaborn, you can use Seaborn, or you can use Matplotlib, anyone. You notice by now that Seaborn and Matplotlib are tightly integrated. They are tightly integrated. If you use Seaborn to create a chart, you can actually use Matplotlib to label that chart or just edit that chart and edit the figure size and all of that. So it's just tightly integrated, just like NumPy and Pandas, Seaborn and Matplotlib, because Seaborn is what built on top of Matplotlib. All right. So Seaborn is built on top of Matplotlib. So this is your scatter plots, all right, between discount and price. We did this in class last week. All right. Um this paper said looks like there are two outliers in scatter plots. This looks out of the distribution here. All right. Sometimes they might be considered outlier, but sometimes they are not so far away to be actually called an outlier. So the distance between this value and the other values is not so great to be referred to as outlier. All right. So it doesn't really impact the distribution or the other values in the data set. So question 8, for the new month column, you create a plot a line chart showing the total quantity for each month. So this is a bivariate analysis, and I specify the figure size to use. So you can as well just draw the plotting and all of that, and you should get something like this, right? You should get something like, it's fine. If you removed it, it's fine. It's fine. All right. It's fine. I'm just saying it. Some people, depending on the work you're doing, that is why every data set is unique. There are some data sets that these values here will actually not be considered an outlier. There are some data sets or some projects you're working on. You don't need the distance to be much. Like everything should be within a very confined range. All right. So depending on the project, so that's why you need to have business understanding and domain knowledge. So you'd just get that. This is your line chart. All right, this is your line chart. As you can see, we have the months of the years here. So you can see that this is not intuitive. There's a way we can align the months to start from January, February, March, and all of that. But yeah, so this is okay. If you did this is fine and all, and it's okay. All right, so you get this. You can see that the highest points here is what? November. All right, that was when the business registered the highest quantity of products sold. All right, so the lowest point was July. July had the lowest for reasons that we don't understand. So these are data science inquiry. Once you see this thing, you can now start asking, why was November the month with the highest quantity? Why? So you can now start gathering more data to explore and answer that questions. All right. So once you understand why November, you can now start creating strategies around your business to either maximize the outputs in November or distribute it or implement the same thing across months so that you get the same number or equivalent number of output or quantity. So this is what data analysts and data scientists do, right? You don't just do chat for doing sake. You do it to be able to answer certain questions, to spot trends and pattern and all of that. So question 9. Also for the this column, plot a bar chart showing the average price for each day. All right, so you can see here. I like what people did here. She tried to align the days of the week to be according to the normal days. So we have Sunday, Monday, Tuesday, exactly. So people created a manual list here, and so that's nice, right? I would like to know who Favor is because I don't think I really see Okay, I don't know if you are here. You can just let me know in the chat, in the live chat. So question 10: which of the products category has the highest quantity sold? So this is just to demonstrate or let you practice how to plot a pie chart. So in this case, you can say electronics has the highest quantity, number of quantity, followed by books and home decorations and food. So this is the assignment. So this is a very interesting assignment. If you took your time to do it, you learn a lot. You would actually learn a lot, right? So that's the essence of the assignment weekly, to build you per week. So by the time you are almost done with the program, you've already learned a lot. When you are doing your project, it's just to just close everything, just to cap it up with a project. All right. So that's it for the assignments. Today we are going to be looking at machine learning. But I said something that we're going to be doing a brief revision, right? I will try to do it under 15 minutes. So we'll use the next 1 hour to go through machine learning. All right. So because this machine learning won't really take time, it's just a conceptual overview. So now we're going to do just revise what we've done so far, and I would like us to just I would like everybody to participate in this, right? I would like everybody to participate. So we're going to be going over pandas, numpy, and matplotlib, and some concepts that we've learned, some functions, and all of that. So I'll be asking questions, and you would answer in the group chat. All right. So um, okay, okay, all right. So just give me a second. Just give me a second. Okay, let's start with pandas. So let's say you have a data frame and you have columns. You have two columns in that data frame, column capital A and column capital B. And you want to rename that column capital A to 1, to column to 1, and you want to rename column B, capital B, to 2, like in words, so not in number. 1 and 2 in words. That is ONE1 and TWO2. So how do you do that? How do you rename these two columns? I need the syntax. I need you to drop the syntax in the live chat. How will you rename a column? These two columns, if you have data frame with those two columns. I'm waiting for a response. The question is not, I'm just saying it. It's not like it's just an interaction. We are not doing any formal quiz here. So my screen, I'm not actually using my screen for anything, so it should be static. All right. Wait, can you hear me? Did anybody get the question? Okay, yeah, I can see some persons are actually answering the questions. So, um, okay, only one person have gotten it so far. Okay, okay. So, I think just one person has gotten it so far, and I'm looking at the syntax. I'm looking at the syntax to be sure that it is correct. So Adeleke Emmanuel has gotten it. So yeah, that's it. So you basically use the rename df.rename function, and in your brackets, your parameter, you have your keyword argument, which is columns. So columns will be equal to a dictionary. So it's inside that dictionary that you now start specifying old column and what new column name. Old column name will be the key, new column name will be the value. So as many columns as you want to rename, you can just specify it in your dictionary. All right, so that is basically how you rename columns in your pandas data frame. All right. So yeah, kudos to Emmanuel. So, I can see other answers. df dot rename and then the old name and new name. You need to ensure that you are putting in columns inside your rename function and assigning it or assigning the dictionary equal to the columns. And also is a dictionary, not a list. So all these things are things that you should pay attention to. There are things that you should pay attention to. And columns is equal to your dictionary. It's not just columns and then your dictionary bracket. All right. So yeah, I think yeah, Emmanuel got that. Adeleke Emmanuel. So let's go on to move on to the next one. So let's say um so how do you reset an index in a data frame? You want to reset an index in a data frame. How do you reset it? And you want to make sure that the index that you are resetting or the index that you are removing does not become a colon, like it is removed entirely. All right, it is removed entirely. So how do you achieve that? We have one minute for that because I know it will take time to type out the syntax. So we have 1 minute, 1 minute, 1 minute. We are done with the first question, so just go right to answering the second question. So someone has gotten it already. So once I bring out the correct answer, then that question is over. All right. The question is, how do you reset an index in a data frame, dropping the old index entirely? Okay, okay. 1 minute I think we've exceeded that. So the person that got this one is Douglas, Umo Douglas. So you have what Douglas did was that you assigned the use reset index function, all right, and inside the bracket it indicates drop equal true. So this drop equal true will drop the old index from the data frame. If you don't put the drop equal true, the old index will now be attached with the data frame as a colon, right? And now either you use in place equal true to make the change permanent, or you assign this entire output to your data frame. So yeah, nice one, Douglas. You got it. I can see other persons here. Adebayo, you've already used in place already, so there's no need to reassign it again to a variable. Either you use in place or you assign it. You can't use two of them at the same time, all right? So yeah, nice one. I can see other persons here. Um is it Nachi, Jifet, Felicia, Adeleke, Emmanuel. Emmanuel, you didn't drop the old index. You didn't just put in place equal true. Okay, so I think we have just few more questions. So this is not because of time. I would not really ask plenty of questions. Let me just ask. I think one last question from Pandas data frame. For Pandas data frame. Okay, let's say I want to I have I want to perform bivariate analysis. I have two variables. Listen carefully. I want to perform bivariate analysis. I have two variables. One variable is a categorical variable, and the other variable is a numerical variable. Now I want to group the numerical variable by according to or by the categorical variable. You understand? So how am I going to write my code? What code will I use? I want to group them, and the aggregation function I want to use in grouping is mean. I want to use the mean aggregation function. So how do I do that? Quick one. We have 1 minute. I have 1 minute. I think this is the last question for pandas, so we'll then go into matplotlib. Okay. His one is already crying that this question no be here. These are the questions that you should know. Right? These are the main questions that you should know. Okay, let me see if anybody has gotten it. All right, all right. I think the first person to get it here is Zainab. Lawal Zainab. Nice one. Group by, then your categorical variable, followed by your numerical variable, right? And then with the mean aggregation. Exactly. So you got it. So that is how you do that. You basically use this syntax in aggregating or performing aggregation. So as simple as grouping in grouping basically. So as simple as that. All right. So that is the last question for pandas. I can see other people answering here. Abubakar, Douglas, Damilola. Damilola, you check your brackets well. You think you almost got it? Okay, I can see Adebayo mean. So what happened is, I think, yeah, what happened is that your first bracket should be a normal bracket, while the second value, which is the numerical, should be in a in a square bracket. So that is the syntax there. So that's just how you do that. So I can see other persons here. I can't mention everybody, but yes, most of you got it correct. So that is it for pandas. That is it for pandas. That is one. So this is just to test you, just to test how quick you can think, all right, and how much you remember from what we've actually done so far. So let's go to matplotlib. So in matplotlib, what is the what is just give me the syntax that you'd use to create a figure of size 10 and 5. A figure that would have the x-axis to be of size 10 and the y-axis to be of size 5. Quick one. Quick one. So that's for matplotlib. Oh, Adebayo. Okay. Salifu. Marvelous. Marvelous. Check your code again. Check your code. Douglas, DM, Kelvin. Kelvin, yeah, you want to give me full code? Damilola, I think almost everybody here got it. I think that is a very cheap one. So the first person to get it here is Adiba, your real one, right? So yeah, you got it correct. So you use plot.figure, and then in your bracket, peak size will be equal to the dimension of your figure. All right, dimension of your figure. Okay, great. Let's move it a little bit higher. All right, let's move it a little bit higher. While let's assume you want to you have your x labels, all right? You have your x labels, and your x axis, actually your x in your x axis you have the ticks for each category. Let's say for a categorical data, and they are long, all right, and they are matching into one another. What are the two things you can do to ensure that the category label are evenly spaced, so that someone that is looking at your visualization can understand the different labels or the different categories? So what are there are two ways you can, okay, mention two ways you can do it. I need just two ways you can achieve that. Two ways. Michael Wanaga Michael. Right? Okay, the question is you have a chart, let's say a bar chart, and you've plotted your bar chart, but in your x-axis, the category names they are tight, all right, to the point that you can actually see any spacing. Everything is just jam packed. So you want to space them so that someone looking at it will be able to understand the different category label. All right. What are the two ways? Everybody just telling me one way, which is the obvious way. I need someone to tell me something else. What else can you do to evenly space your your category label or names? Yes, it was S ticks, S ticks, S ticks. All right. Michael was first going to say S ticks, but there's another thing you can do. I need you to think. Like, what do you think you can do? Increase the width of what? Mercy, you're saying something. Increase the width of what? Of is it the bars or what? Decrease the width of the bars. Shorten the names of the. Okay, let's assume you can't actually change the names. You can't change the names. You are working with those names. What can you do aside shortening the? Decrease the width of the bars. Decreasing the width of the bars won't do anything. It won't actually change it won't affect the labeling of each bar, right? It won't. So, I'm just waiting for someone to say that thing. I'm just waiting I just want to give maybe a few more seconds to see if anybody can capture it. Abubakar Amidu, increase the width of the axis. How? Abubakar, can you explain what you mean? Abubakar, you said something, increase the width of the bars. What do you mean by that? Exactly. Thank you very much. This is what I'm looking for. Increase the fixed size of the x-axis. Like that is just it. Imagine assuming your bar chart is jam-packed, just go to your figure size and increase the width of your x-axis. So it will be your chart will be bigger and it will have enough space for each of the category name to be. You understand? Thank you. I wish this was in live class. Thank you very much, Abubakar, for that, for thinking outside the box, right? Thank you, thank you, thank you, thank you. That is exactly what I'm looking for. All right. Um. So so is it how do you do that? Yeah, you just go to your fixed size, plot the figure, and change the fixed size. You can if your fixed size was initially 8.5, you just change it to like 12.5. It will increase the length or the width of your figure. So it will have your X6 will have enough space for the labels to be, right? So you can try it out yourself. Thank you very much. So for answering that, okay, let's see if we can ask one more question in Matplotlib before we go to NumPy. All right. So let's see. Which other question can I ask? Um let's see. What does the alpha parameter do in plot or in charts? What does the alpha parameter do? Just a very simple question. What does the alpha parameter do? What does the alpha parameter do? And what is the range of the value of the alpha parameter value? What is the range? So as you're answering it, you just also give me the range. What from what range to what range? What is the range of the alpha parameter? What value does it take? I'm waiting for us. I'm waiting for us. After this, we'll just go straight to what we have for today. I think we have none. We've not done NumPy yet. All right. Yeah, we'll just quickly do NumPy and then we'll go straight. Okay, okay. Um, okay, Adebayo real one. Control transparency. Yes, you are correct. You are correct. You're the first person to get that. That is nice. So let's see if another person was able to answer the second part. Lawal Zainab, 0.5 to 1. Are you sure? 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 All right. A team for transparency, Dauda Tijani, 0 to 1, exactly. So yeah, we get it. We are got it. So the value for the alpha parameter, what the alpha parameter does is controls the transparency of the plot elements, exactly as Peter put it. Peter Simfa. I think you're the one that even captured it very well because others just said control transparency. So Peter, I think I will go with Peter's one. Controls the transparency of the plot elements. All right, that is what it does. So if you have a bar chart, it will control the transparency of the bar. If you have a line chart, it will control the transparency of the line. If you have a box plot, any chart there is to control the transparency of that plot element. And the value is usually range from 0 to 1. All right, so thank you very much for that. So Chuku Kawokolo, yeah, thank you for that. So yeah, that's it for Matplotlib. I wish we have more time. We'll go in depth. Yeah, let's quickly just go to NumPy, quick one. So for NumPy, what is the primary purpose of NumPy? What is the primary purpose of NumPy? GFET, really GFET, numerical computing. Okay, yeah, that's okay, right? But I need a specific answer. There's something I want to hear. Numerical computing, exactly. Okay. Nkechika Collins, for working with arrays, yes. Exactly. I think this is a more specific answer. Don't get me wrong, numerical computing is correct. Like if you say it is correct. But the array processing is the more accurate answer. NumPy is specifically made to process arrays, all right? So it's in that array that you now have numerical or numbers and all this computing stuff. But the main thing is working with arrays, right? Processing arrays. So yeah, Kichika, I think this one goes to you. You got that. So everybody that said numerical computing, you got it too. Like, don't get me wrong. We talked about it in class, so you got it. But I think that one is more specific and captures exactly what I want to hear. All right. So let's see. One or two more questions basically. Um so what's the purpose of flattening function in NumPy? What's the purpose of flattening function? Quick one, very simple. What's the purpose of flattening function in NumPy? np.flatten, what's the purpose? All right. We have Lawal Zainab. Okay, we have Tolulope first. Returns a copy of the array collapsed into one dimension. Okay, I'll take that. That's okay. That's the answer, right? It collapses any array into one dimension. Kechika, to reduce the size, I don't think so. Lawa was enough for converting 2D to 1D. What of 3D? What happened to 3D? Are you leaving that one out? Okay, yeah, I think the developer got it. It is basically flattens or collapse your array, regardless of the dimension. Any dimension you give it, it collapses it into one dimension. All right, Merci to collapse the arrays into one. Um, Precious also introduces the higher dimension to one dimension. So yeah, I think most of us yeah get it. That's okay. Last question in NumPy. Last question. So I think this one goes to is to well done. You captured the answer. So last question. What's the difference between np.sum and np.add? Last question. What's the difference between np.sum and np.add? I'm looking for a very detailed answer. Um, yeah, Kelvin gave me the answer he wants for np.add, but it just for np.add. What of np.sum? Okay, patient. Okay, Temitope Jennifer. np.sum is an aggregate function. You got that? You got it. What of np.add? Patience. Sum is for aggregate. Why add is for single element? Hmm. There are words I'm looking for. You are getting it. You're getting it. But there are reasons why we have jargons in different fields because they're able to capture the exactness of that thing, that concept. So I'm looking for some particular weddings. Um yeah, I think I got it now. Tolulope again. np.sum sums up the whole element in the array, while np.add only sums it up element wise. What do you mean? You are getting the wording, but your explanation is not given, right? It is not right. It's still not given. np.sum gives precious. np.sum gives data of an array, while np.add adds up the element wise. But let me see if I can get something that I want before I just say. Um, Oluwadoyin Kuti. np.sum only works on one value. I think you have an idea, but you're not capturing it well. Yes, I think this is what I'm looking for. DN, echo DN. np.sum is for aggregation, while np.add adds two arrays element wise. That is what I'm looking for. Like, and that is the difference. np.add works on two more than one array. You understand? And it performs element wise operation on those two arrays. While np.sum works on just one array. I think you didn't get that in the np.sum, right? You just said np.sum is for aggregation of one array. So that is the difference. That is the answer, right? So I think that is just it. So. Okay, I think Adeleke Emmanuel got it here. np.sum will sum all values is in an array, while np.add will add up two arrays together and keep it okay. Yeah, so we've gotten it. We've done very well. That's going to be the end of this particular session. I hope we all enjoyed it. Please let me know if you enjoyed this, if you actually enjoyed it. And I enjoyed it actually. If we had more time, I would have kept on going, but we need to go into today's class. All right. So this should be a motivation to if you see that, oh, there's some things you're not remembering, it should be a motivation and then it kind of push for you to go further and revise what you've learned already. All right. So what is happening is just that you've probably just forgotten some of these things, and it's normal. So you should go to what we've done so far and revise them so you can remember how to do all these things that we've talked about today. All right. So that is it. That is it. Let's move on to today's class. All right. Let's move on to today's class. So today, as you can see on the screen, we are going to be talking about ML, machine learning. Okay, so machine learning is a very interesting field, like very, very interesting. All right, I'm very sure most of us here have heard about machine learning. Like, if you have not, I don't know, maybe you are living under the rock or something, but as long as you're in tech, you should have heard about machine learning. So machine learning is what we're going to be looking at today, and is tightly related to data science, but it's not entirely. It's not. We are going to show the relationship, right? But yeah, so let's move on. So the outline for today's topic, we're going to be looking at the overview of machine learning, types of machine learning, steps in a machine learning project, core machine learning algorithms, model evaluation techniques, practical application, and machine learning library. So we're just going to look at them one after the other. Here is your learning objective. At the end of this class, you should understand the fundamental concepts and importance of machine learning. Learn about different methods, including supervised, unsupervised, and reinforcement learning. Know the life cycle of a machine learning project from data collection to model deployment. Know the essential algorithms like linear regression, decision trees, and neural networks, and understand what evaluation of a machine learning model is. So these are the things that you should know at the end of this particular class. So we're going to go over them. Now, what is machine learning? What exactly is machine learning? As you can see on the screen here, machine learning is a branch of artificial intelligence that should be at the back of your mind. Machine learning is a branch of artificial intelligence that focuses on building systems that learn from data. All right. So the same way human beings learn is the idea that computer scientists is trying, ML researchers are trying to replicate in computers. All right. So the traditional means of programming is usually we giving our computer instructions. Okay, this is what you are going to do. You use if statement and all of that. For example, if you want to teach your computer to recognize the image of a cat, traditionally without machine learning, you will have to start hard coding all the features of a cat. You can now start saying if they are 2 years, then and the 2 years are pointy, so you are going to write a lot of if statement. If the image the cat is as 4, if the cat is this size, if the cat is this, all those things you have to go through the rigorous process of highlighting and specifying all the details. But the problem with that is that there are a lot of cats, so all cats don't fit into the same category. There's some cats that will actually not be able to capture the features with your code, right? Traditionally. So that is why machine learning is very important. Machine learning is the reverse of that programming method. Instead of you telling your computer what to do, you are not telling it what to do. You are just giving it data, feeding it a lot of data, a lot of cat data, all right, images of cats, and then applying an algorithm, right? So you give it data plus algorithm, and then the machine by itself will go through all the images and use that algorithm to process the images and learn features from those images. All right. So that is what we call training. You are training a machine learning model. So we're going to look at that, right? But basically when you're doing that, you are training your computer to learn how to recognize a cat. So you don't need to start hard coding everything. Okay, if the cat is this height, if the cat is so and so pound, if it is 5 kg or 10 kg. So no, you know those things. The computer will learn by exposing it to thousands and millions of images of cats. So it goes through all these images, finding patterns. And the way it finds patterns, we don't even understand it. All right. So people have not, with machine learning engineers, they're not able to understand exactly how this machine learns these intricate details that they now use to understand that this is a cat. So once you have finished training your computer with a lot of data with an algorithm, then you are now going to have a model. So that model can now actually tell you if a cat is a cat. My screen is not moving. I'm not moving my screen. I'm just explaining. That model will be able to tell you if a cat is a cat. If you give that model an image of a cat, let's say you just go outside and you just snap a cat, and you bring that image, pass it to your model that you've trained on a lot of cats. That model will be able to recognize that, oh, this is a cat, without you telling it that this is a cat. Why? Because it has learned. It has learned. That is what machine learning is. It has already learned from data that you've passed to it. All right. This is just the overall idea in machine learning. I don't even need to go further to explain more. If you understand this thing I just explained now, you've understood what machine learning is. All right. And machine learning is the building block of artificial intelligence. So artificial intelligence is a broader field that encompasses machine learning and all other techniques, right, to enable computer to behave intelligently. All right. So that is it. So let's just go over the definition. Machine learning is a branch of artificial intelligence that focuses on building systems that learn from data, very important, identify patterns from that data, and then make decisions with minimal human intervention. So you don't need to tell your computer that this is a cat. Your computer will know that this is a cat without you telling me. So that machine has already learned. So as a data scientist, whenever you are building a machine learning model, you are building a machine learning model to be able to predict something without you telling it what it is. All right. So that is the essence of machine learning. That is most of the things you'll be doing in machine learning. All right. So for example, you see, let's say a CCTV camera, all right, that is placed, let's say, to monitor let's say in a company, there's a face recognition camera that is placed to identify the workers. So as each worker is entering the office, the camera will look at the face of the person and automatically know that, oh, this person is part of the employees, and it will open the door. So that kind of use case is also an application of machine learning. So they've trained that particular camera. They've trained a model basically to be able to recognize the face of the employees in that company. So whenever they see a particular face, they'll be able to know that, oh, this person is an employee without you telling the computer, all right? So there's a way they embed it into the camera. So the camera will be able to take the images, and the image that it takes will be processed by the model, and whatever the output the model gives would be used to make decision whether to open the door or not. If the image is not part of the employees that are in that company, the door, it will not open. So there are vast application of machine learning, right? There are a lot of it. Everywhere you turn, machine learning. Another instance is self-driving cars. I don't know if you've seen this particular self-driving car. I think is Waymo. Waymo is in California, USA. So it's just like Uber. It's a very big company, no, but like Uber. But this particular Uber, there is no human being driving it. And I'm very serious about this. I don't know if any of us have seen it. There's no human being driving it. You just go to your phone, open the app like you would order Uber or Bolt, order that particular Waymo car, and it will come and meet you where you are. Nobody's inside the car. Nobody is inside the car. It will come and meet you in your location. you open the door and enter, and you press start trip, the same way you press for Uber, the car will take you to your destination without anybody inside that car. This is an application, this is AI, this is artificial intelligence that applies machine learning. So the car has been trained to learn how to drive. Although the self-driving car is multifaceted, meaning that it involves a lot of different complexities. But the core of the matter is that it uses machine learning to learn a lot of things about the environment, to learn when there's someone crossing the road, to learn that, okay, this is red light, this is green light. So when it's red light, I will stop. When it's green light, I will move. To learn speed limit, when it sees a sign of speed limit, it will know that speed limit and it will reduce its speed to maintain. So there are a lot of things. The main thing is that the computer in the car has been trained to learn how to drive without human intervention. So whenever someone says that AI, machine learning is the future, it is the future. So you that you're in data science now, you are actually future proof. Because we are the one, if you want to go into ML and AI engineering, you'll be the one building these systems. All right. The application is you can't even count. It is so vast that it applies to any field, to healthcare, talk of healthcare, talk of agriculture, talk of aviation, talk of transport, talk of what have you. Everywhere AI is applied, right? So that is actually why it's good you are here, right? To understand the fundamentals, all right? Although there's a lot more to building AI systems than this. So this is the fundamentals that we're going to be looking at in this program. So that's it for machine learning. Let's quickly move ahead. So the significance of machine learning lies in the ability to perform complex computation and process vast amounts of data at a speed and accuracy that human can't match. Now, the reason why we have machine learning now is because the amount of data has skyrocketed. The amount of data we have in the internet is humongous. All right. So that is why we're able to train all these machines with a lot of data. So they understand patterns, they understand things that we human beings self we can't really understand. They understand details from those millions and billions of data sets that you give them. All right. So that's how they learn, and they learn patterns, and those patterns is what they use in understanding and making predictions. All right. So the same thing with ChatGPT. ChatGPT also was built with this idea, with this concept I'm explaining, although it's a different thing entirely, which is out of the scope of this particular program. All right. So I don't need you to understand the applications of this. So the reason why we have machine learning now is because of explosion of data and computing power. All right. Explosion of data and computing power. These are the two things that is enabling machine learning. The algorithms that are being used in machine learning, they've been there for decades. People have been bringing out research paper with algorithms, although they are newer algorithms, right? But the reason why we are having an explosion of AI currently is because of the amount of data that we've been able to generate globally, and also the computing power. Computers have become faster now, right? So you can actually train this machine learning with powerful computers to be able to understand patterns in your data sets. All right. So that is just it. So these are the things that you need to know. Right. So application of machine learning can be seen in everyday life through recommendations on streaming services, voice recognition software, and even in critical areas like health and finance. So, as I said, machine learning is applied everywhere. Everywhere you go, you can actually apply machine learning. So, let's look at the intersection between machine learning, AI, and data science and deep learning. So, this is the relationship between these three. You can see that data science is just taking a part of the this particular field. So data science is a different field on its own, but it takes from machine learning, right, to achieve some task, to perform some tasks, all right? So that is what we are doing. That is actually what we are doing. But machine learning is a different field on its own, right? It is under the umbrella of artificial intelligence. Artificial intelligence is a broader field that involves a lot of things, machine learning system, robotics, and other systems, right? But machine learning is part of it. And under machine learning, we have another thing we call deep learning. Deep learning is a subset of machine learning. So hope you are still following. Hope I want to be sure that everyone is still following me up to this point. Please let me know in the group chat. Please let me know so I'll proceed. All right, great. So deep learning is a subset of machine learning. All right. It's out of the scope of this program as well. But deep learning is what we use in AI systems actually, right? What we are going to be doing in this program is just traditional machine learning techniques. We're not going to be doing deep learning. Deep learning involves neural networks. So when you hear of neural networks, then you know that, yeah, this is pertaining to deep learning. That's where deep learning comes in. But what we are going to be doing in this program is using traditional ML algorithms like linear regression, logistic regression, decision trees, random forest, and a lot of them. So we are going to be looking at them like subsequently in this class. All right. So this is the relationship between them. So data science just cut off, takes from this field of AI, machine learning, and deep learning, and applies it to businesses. So data science, the end goal of data science is actually to provide business value from data. All right. So if machine learning is a technique you can use, then use it. So that is why we are having this interaction here. All right. So we have other fields like ML engineer. ML engineer is a different field on its own that fully focuses on ML, building ML systems. So ML engineer and data scientist, they are two different people. But as a data scientist, you can actually become an ML engineer. All right. ML engineer, their own is fully machine learning. Everything they're doing is machine learning. They don't think about businesses. They don't think about how to generate insights. They don't think about all this value from data. That one is just to build machine learning model and use it to make predictions and all of that and deploy it. We also have AI engineers. So those ones, they also do similar things as well, but their role is actually broader. So that is what I need you to understand from this diagram you can see here. Let's proceed. So we have types of machine learning. We have three types of machine learning basically. We have supervised machine learning. You can see it here, supervised machine learning. We have unsupervised machine learning, and we have reinforcement learning. Machine learning can be broadly classified into three types: supervised machine learning, unsupervised machine learning, and reinforcement learning. In this program, what we'll be doing is only supervised machine learning. Majority of the ML algorithms, the ML work tasks that are being used, like mostly, are supervised machine learning. All right. It's not like we don't use unsupervised machine learning and reinforcement learning. They are used, but supervised machine learning is the most common. So we're going to look at that in the course of this program. We don't machine learning is very broad, all right. So that's why we are narrowing it down to the one that you would be using most of the time, all right. But I'm going to explain what these three machine learning types are. So supervised machine learning. This involves training a model on a labeled data set. Now, please pay attention. I need you to understand the difference between supervised machine learning and unsupervised machine learning. Supervised machine learning involves training a model on a labeled data. Let me just make this thing on a labeled data set. Now, why we call it supervised is because as we are training the machine, during training, we are also telling it the answer. That is just what supervised is. We are telling it the answer as we are training it. So it is able to learn the answer of your maybe data. Like let's say if you give it an image of a cat, normally the machine doesn't know what a cat is. So when you are training, as you're giving an image of a cat, you also tell it at the same time that, okay, this is a cat though. You understand? You tell it, you bring label and attach it to that data so that the computer will know that, okay, the label for this image is a cat, so it will now start to understand that relationship. So that is what we call supervised. You are supervising it. You are working with it. Like, okay, see, this one is a cat, oh, this one is a dog, oh, this one is this one is that, this one. So it will understand the relationship in your data set. You understand? So that is what supervised machine learning basically is. So this involves training a model on a labeled data set where the correct output is known. All right, so the output in this case can be what I just mentioned. The output can also be, let's say you want to predict the price of a house based on certain features in that house. Let's say the number of bedrooms, the number of stories, the distance from city, if there is water available, and if the house, how old is the house, and all of that. So all these things are features that you can use to predict the price of a house. So if you have this data set, these features are what you use, and the price is the label. All right. So you have that data set, and that is the data set you use to now supervise your computer, training needs to learn the relationship between the label and the features. All right. So we're going to look at how we'll do all these things in more details. So just don't worry so much if you're not getting it completely at this point. For some of us it's completely new, so it's okay if you are confused about some certain things. But just follow us. Just try to follow as much as you can. You can go back to this recording and look at what we've said over and over again. So the goal for unsupervised is to learn a pattern that maps inputs to the correct outputs. Common applications include spam detection. Spam detection is what is being done most of the time in your Gmail. So if you go to your spam folder in your Gmail, you see a lot of spam email there. That thing is machine learning. Machine learning is what is actually sending those emails to spam, because it has been trained to learn the difference between a spam email and an email that is not spam. So any email that is being sent to you will go through that machine learning model that has been created by Google, because Google has Gmail, right? So the output can either be, yes, this email is spam, or no, this email is not spam. So if the email is spam, the decision will be take it to the spam folder. If the email is not spam, the decision will be, oh yeah, take it to the inbox of the person. All right. So this is an application of machine learning in your phone currently. All right. So, but we are still going to talk about the different machine learning tasks, because we have two. We have classification and we have regression. So what I just explained now is a classification task. All right. So for supervised learning, it's even further divided into two types. So we're going to look at that moving forward. So we also have another example, real estate prices. So I have explained that when I was giving an example of when you want to predict the price of a house. So the features you would have in this case, it can be any feature basically, but you just want to have things that you can use to predict the price of house. All right. So the same way as human being, when you maybe you want to buy a house, or let's assume you want to buy a house, you gauge the house from outside. You look at certain features. If the house was newly built, if the house is like two-story building, if it's a duplex, if it has several rooms, if it's located in the city, you would know, like subconsciously, you would begin to already attach a price to that house. Now, oh, this house will not be cheap. Oh, this house will be like above 50, 100 million, 150 million, that kind of thing. You understand? So you're already using the features that you can see in that house to make a prediction already. That is the same thing that machine learning, supervised machine learning, is trying to do. In this case, this example of real estate pricing, you are giving it certain features like the house, how old the house is, if the house is a duplex or not, if it's a bungalow, if it's located in the city, if it has water running, and all of these things. So the computer will take all these features and now use them to learn. Although during training, you give these features, all these features, together with the real price, right? Because you are trying to supervise the machine. You are giving it the answer during training, all right? Keep that at the back of your mind. So during training, you give the machine the answer, so it sees the answer. So it learns to the relationship between the features and the price. So once you've trained it finish, you can now make predictions. So you can now give it a new house features that it has not seen before. So based on the features you gave it and based on what it has learned during training, it can now give you a price based on its knowledge that it already have. All right. That is basically what happens in machine learning. So our goal as data scientists is to ensure that these models that we are creating, they are giving accurate outputs, that their predictions are as good as possible. Because these things are used in real life situation. We don't want them to be making mistakes, costly mistakes. Understand? We don't want to be making costly mistakes. All right. Although there are some things that are not very expensive mistakes, like spam, right? If a spam enters your inbox, you can as well just move back to spam. It's not really going to cost you much, but it's inconveniencing. You understand? But there are some mistakes, like for example, in the health sector, when you want to build a machine learning model to be able to detect if someone has cancer or tumor in their brain, you take the images of their brain scan and you use those images to train a machine learning model to be able to identify the scan that has tumor and the scan that does not have tumor. So when you give it a new scan image, it can tell you with precision whether this particular scan has tumor or not. So you don't want to make mistake in that kind of thing. You don't want to. That is why as a data scientist, you will be doing a lot of evaluation on your machine learning model to give very, very accurate predictions. There was one trending news recently that a machine learning model, an AI system, was able to detect breast cancer 5 years before the cancer developed. Can you imagine? Like even before the doctor is able to detect the cancer, the AI was already able to see the image of the breast. That is the radiological image, all right? Because the radiographer, they take images, radiological image and all of that. If you've done breast scan before, you understand what I'm saying. It sees this image, the machine learning that has been trained on thousands and millions of breast radiological images and all of that. It now sees an image and is now able to make prediction on whether this particular image has potential of developing breast cancer. So the news it actually blew up, and it is saving lives. All right. So these are the real life applications of machine learning. And this type of machine learning, all of them are supervised machine learning. All right. Yes, they are labeled. You train them with supervision. You give them answer. So when you are training the breast tumor detection, you give it an X-ray image, all right, and you tell it that okay, this particular image it does not have tumor. Okay, you give it that is one data. You bring another data. This one has tumor. You give it to learn it. So you give it like thousands of data with that particular data structure, label and image. So you give it thousands and millions of data sets. So it learns patterns with an algorithm. All right, and is able to create a model. A model is like a knowledge structure. All right. So let's just move ahead because we still have things to we still have some things to like talk about. Let's for supervised machine learning. Unsupervised machine learning is the opposite of supervised machine learning. So in unsupervised machine learning, the data is unlabeled. It's just like we are teaching it, but we are not giving answer. We are telling it, oh yeah, learn on your own. Try to understand this data by your own, on your own rather, without label. All right. So for example, if let's say you have a customer database and you want to understand the categories of your customer, right? There is no label to whether this customer are top tier customer, this customer are middle tier customer, this customer are the lower tier customer. There's no label like that. But you want to be able to classify those customers into different categories. So this unsupervised machine learning is a very good approach to achieving that. You can pass the data into the algorithm, all right, the ML algorithm, and the ML algorithm can actually look at the patterns and categorize the different groups, categorize the data into different groups. All right. So you can now start to label them and say, okay, this particular group is for top tier customer, this particular group is for this one and this one. So this is what unsupervised learning or machine learning does. All right. So as you can see here, unlike supervised machine learning, unsupervised learning deals with unlabeled data. The model tries to find underlying structure or distribution in data to learn about the data. So you are not telling it the answer. It's trying to learn the answer on its own. So the most popular task in this unsupervised is clustering. So clustering is what I just explained. Clustering is like looking at a group, a data set, and clustering it into different groups, all right, based on similar features. Okay. So that's for unsupervised. We now have reinforcement learning. So this reinforcement learning is like you might not even do it, or depending on your interest, but it's basically like it's used in robotics, basically in robotics, in training robots, right? So it is a machine learning technique that learns that as an agent can be anything. It's used in training games, right? You know these board games we have that you play on your phone. Let's say you want to play chess on your phone, and they ask you that you want to play with a person or you want to play with a computer, and you choose computer. That computer was trained using reinforcement learning. All right. So it understands how to play the game based on how it has been trained. All right. So it knows different things. So that's why sometimes it's very hard to beat these computers because they've already mapped all the possible moves and all of that. So they know. So that is what happens in reinforcement learning. An agent is what it is called. It can be a robot that is trying to navigate an environment to be able to explore the environment and all of that. It can be a game that can be played on its own without an human intervention and all of that. So it learns to behave in an environment by performing certain action and experiencing the rewards or penalty from those actions. So I don't want to go deep into the reinforcement learning, but this is basically what it is. So it is extensively used for gaming, navigation, and robotics. So that is what I just explained now. So these are the three types of machine learning: supervised, unsupervised, and reinforcement learning. So as you can see on this chart here, it illustrates, it gives a further illustration of the three types: supervised, task-driven, unsupervised, data-driven, and reinforcement learning from mistakes. All right, so let's move on. Now we're going to look at the steps in a machine learning project. So whenever you have a machine learning project, although we've talked about it initially at the onset of this class, all right, we've talked about it, but I'm going to look at it again. Now, this is a typical machine learning life cycle. First thing is data collection. You get your data, all right. Second thing is data preprocessing. You can see that we've skipped. What do we skip? Can someone tell me what we skipped here between data collection and data preprocessing? Can someone tell me what we skipped? Yeah, Adebayo one, you picked it. Although yeah, though that Tijani, the EDA is what it is. EDA is what it is. So we skipped EDA here because that's not our focus in machine learning. In machine learning, we don't care about exploratory data analysis, right? But in data science projects, you would actually involve EDA. But in machine learning project on its own, most of the time you are not required to do EDA. You just go straight to building your model. Go straight to building your model. That is the focus in machine learning. But in data science, you would actually incorporate all these other extra steps. So some of you are mentioning cleaning, which I understand, but in pre-processing, we actually clean our data. All right. So cleaning it happens during pre-process. So in machine learning, you collect your data and then you pre-process it, and then you after you pre-process it, you select your model. All right. So we're going to look at all of these, right, step by step in the next weeks. Like that's what we're going to be doing to the end of this program. All right. So after you've selected your model, then you train the model, which I've explained with your data sets. All right. So let's just look at the explanation. So data collection, gather the raw data from various sources, data preprocessing, cleaning and organizing data into a suitable format for analysis, model selection, choosing an appropriate model based on the problem type, training the model, teaching the model to learn from the data. All right. So then after you've trained your model and you've got you can now start evaluating your model. This model evaluation is what I was talking about to ensure that your model prediction is good and it will be able to generalize well and make good predictions. So in this model evaluation, we assess the accuracy of our model. So there are several techniques we can use to do this, a lot of techniques for evaluation. So all these steps, we're going to be looking at them, right? Aside data collection, all right? So from pre-processing to model selection to training the model to model evaluation. So these four steps, we're going to be looking at them in the course in next weeks, right, to the end of the program. Deployment is usually the last step of machine learning project. This is where you now deploy the model to be used by people all over the world. All right, but we're not going to be doing that in this program. It's a different thing entirely that will take a whole lot of time to learn. You have to learn some backend stuff. You learn how to use Flask API or Fast API, or start learning how to use Streamlit and a whole lot of other things. So that is a whole different thing entirely. So in a company, the deployment is usually done by the backend engineer in collaboration with the ML engineer. All right. But you are advised to also learn the deployments. After this program, if you are still interested in furthering in machine learning, you can as well learn how to deploy model after you've trained them. So it is an illustration of the process. Train your data. You get your training data, you get your algorithm, and then you would use this algorithm to learn from the data, and then you get a model that you've trained, and then you can now start using it to make predictions. So this is basically the machine learning process. All right, so we're going to now look at core machine learning algorithms. So algorithms are very important in machine learning. These algorithms basically is a step-by-step process of solving a problem. So different different tasks require different algorithms. So what we are actually going to be learning, we're going to be learning different ML algorithms because it is these algorithms that works on the data. Right? You remember I told you that the machine learns from the data. The way it learns is through these algorithms that we're going to be looking at. That is actually how it learns. So these algorithms is a process that tells it how to learn from the data. You understand? So there are several core ML algorithms we're going to be looking at. We're going to be looking at linear regression and logistic regression. So I think we'll look at linear regression tomorrow, right? And logistic regression next week. So these are used for predicting continuous outcomes and binary outcomes. Right. So look at all these concepts you are hearing. We are going to be breaking them down so you understand what they are. You understand you understand what continuous outcomes are and binary outcomes and all of that. So we have linear regression and logistic regression. So if you are familiar with mathematics, you should know this thing. Like this is a mathematical statistical concept that is popular. Another one is decision trees and random forest. So this is another machine learning algorithm that we are going to be learning as well, right? We have support vector machines. So this is another one again, right? So I think we also have we have other models, we have other algorithms that we're going to look at, all right? So we have neural networks. So we're not going to be looking at these ones, but this is an algorithm in machine learning. So this neural network has its own classes of algorithms that are under deep learning. So these ones are actually even more complex, right? They are more complex, right? So, but it's out of the scope of this particular program. But this neural network is what you use in all this AI stuff you are seeing in ChatGPT, in all these things, basically, right? So this is the basis for deep learning. It's the idea for tasks like image and speech recognition. So if you use Google Assistant, whenever you say, "Hey Google," and you start speaking, the translation that happens as you are speaking, it is translating it to words. This is machine learning. It is taking the audio input from you, right, and converting it to text. So this process is achieved using deep learning. All right. So it's called speech to text. So all these things are machine learning is very interesting, trust me. Like it's very, very interesting. So we are going to build the foundation for you in this program. So we'll look at all this like this various algorithms we've mentioned: linear regression and logistic regression, decision trees, random forest, support vector machines, right? So that is it for the algorithms. Now we'll look at model evaluation techniques. So this is just to just give you an overall idea. We are not explaining. We'll go in depth into all these things in subsequent classes. All right. So I told you that model evaluation happens at the later stage of your ML process after you've trained your model. All right. After you've trained your model, you need to evaluate that model to be sure that this model is performing well. All right, so that is what model evaluation is. So we have different techniques in evaluating model. And it depends on the particular task that you're performing. Remember, I told us we have two kind of tasks: classification task and regression task. So tomorrow we're going to look at it and how we apply different evaluation techniques to the different tasks. These two different tasks that we mentioned. So we have confusion matrix, right? We have cross validation, we have ROC calls and ABs. So all these things that was sounding like jargon and a lot of like just sounding too big for it. Don't worry. Trust me, just come to classes. By the end of this program, you look back to this particular class like, so this is what I was finding difficult to like understand. This thing that is easy. That is so the same way when you started Python, for those of us that started newly in this program, looking back now, you'll be like, wow. So this is the Python that I was scared of, or the Python that was looking daunting. So it's something that would happen now. So it just requires you to believe in yourself. It requires you to just be confident about your ability to learn. Right? Don't allow it scare you. Don't allow it intimidate you at all. These things are normal thing. Like trust me, they are not hard like that. It just requires your effort and your commitment to attending classes and doing the assignment that I will be giving. All right. So now that we are done with this already. All right. So we'll just look at practical application. So this is what I explained earlier on, right? The machine learning process. All right. So you define the problem, prepare your data, choose a model. This prepared data is still something as pre-processing. Choose your model, train your model, evaluate and tune your model. This usually go hand in hand, these two, and then deploy your model, right? So that is it for that. Now let's look at the libraries we're going to be using. Remember, we've been using machine learning, different libraries for different tasks. So for machine learning, we're going to be using a specific library to do all the things we'll be doing. And in the course of this program, we're going to be using scikit-learn, right? Scikit-learn is a machine learning library in Python that can perform a whole lot of machine learning tasks. It makes it easy for you to build machine learning models, right? You will see it like in the I think either next week or next 2 weeks. We're going to introduce scikit-learn after we've explained a whole lot of all these concepts. So scikit-learn is one of them. That's what we're going to be using. It's used for general machine learning. All right, this for general machine learning. You can see yes, scikit-learn is perhaps the most well-known Python library for machine learning. It provides simple and efficient tool for data mining and analysis. It is built on NumPy. You can see it now. You can now see the relationship again. It is built on NumPy, SciPy is scientific Python, which we didn't look at, and Matplotlib. So you can now see the interaction between all these models, all these libraries rather. So it includes support for various machine learning tasks such as classification, regression, clustering, and dimensionality reduction. So all these things, they are jargons that you get used to. Trust me. All these things, your classification, regression, clustering, dimensionality, so just you would get used to them. They will become part of your vocabulary in few weeks. So don't get intimidated. So we have another library, TensorFlow. We are not going to be using this, so but just for you to know, we have Keras. So TensorFlow is used for deep learning and neural network, which I explained. All right, it was developed by Google, and you can see all the description here. We have Keras. So Keras and TensorFlow are actually together now. So they merged. So we have Keras inside TensorFlow. So they basically do the same thing, deep learning. We also have PyTorch. PyTorch is almost similar to TensorFlow. It's just that it was developed by Facebook, right? So it does the same thing as TensorFlow, but it was developed by Facebook. So it's like a competition to TensorFlow. So you can use either of them to do the same thing, all right? So it is used for deep learning. So sklearn is not used for deep learning. It's basically used for general machine learning, traditional machine learning. So it's what you're going to use as an intro. It's basically where you're going to start from when you're learning or trying to learn machine learning. Learn machine learning. That sounds deaf somehow. All right, so we have another one here. I think the last one, XGBoost. So XGBoost is a very powerful ML algorithm that we're going to look at. All right, we are going to understand what it is and what it is used for. But this is a library also that is specifically used for gradient boosting. It's particularly used for a purpose. All right, so this is an ML task, an ML algorithm basically that can be used for classification or regression tasks. So it's a library, and we're going to look at this library as well. So each of this library has its own strengths and specific use cases, and they often are used in combination to cover different aspects of machine learning and data processing. So yeah, all these things are just English. These things are what would help you to achieve your purpose of building machine learning model. But for the course of this program, we're going to be looking at sklearn or scikit-learn. All right. You would learn the same way you've learned NumPy and pandas and matplotlib is the same way you will learn scikit-learn. All right. So that is it for today. We've actually introduced machine learning to us. Let's see the outline again. We looked at the overview of machine learning. We looked at types of machine learning, steps in a machine learning project, core machine learning algorithms, model evaluation techniques, practical applications, and machine learning libraries. So we'll be able to cover everything. So if you look at these learning objectives, you should understand, you should be able to answer or align yourself with these objectives. All right. So that is it for today. Welcome to machine learning, right? We actually have a journey ahead of us, and it's going to be an interesting one. So I need you to buckle up, sit with me in our bus because it's going to be a long ride and it's going to be an interesting one. So in this case, I am the driver and you're the passenger. So please don't step out of the bus. Just buckle your seatbelt and enjoy the ride. So welcome to machine learning, and please don't give up. I can see I can sense that some persons are already like, oh, this was not what I signed up for. This is not what I signed up for, Rara. So what is all these things that we are seeing here? See, you would enjoy it, trust me. You would enjoy it. I can start telling you stories of people in cohort one that had the same stories. Like they have no idea of what Python was. They have no idea of what machine learning. But after this program, they are now comfortable. Some of them were reaching out to me that someone gave them a project to work on, like a paid project to work on, and Someone that didn't have any knowledge of machine learning is already building machine learning model and doing things like it is still a surprise to them. So the same thing is going to happen, all right? The same thing is going to happen. You are going to actually surprise yourself if you keep up. You're going to actually shock yourself if you keep up. So don't give up, all right? Don't give up. You've come so far to give up actually. So that's it for today's class. We I want to know who Favor is. Wait, Favor, you've not identified yourself. You've not identified yourself. Okay, I think I've seen you already. Yeah, I've seen you. Okay. Um. All right. So that is it. Please, if you have question, you can start asking your question now. We'll be rounding off in a few minutes. Please, if you have question, just raise your hand and I would call you up. Any question? Any question? Any question? Please, Jack, if your question is about the assignments, just drop your hand. Please, just drop your hand. Just make sure that the question you're asking is pertaining to what we did today. I don't want someone coming up to start telling me about assignments or something about submission and all of that. Please, please, I'm begging now. All right. So let it be pertaining to what I've already told you already that after this class you should reach out to me and then we'll see what we'll do regarding that. So hopefully it is not about that. All right. So I'm going to just start with Nicodemus. Please unmute yourself and ask your question. Nicodemus.
Hello, good evening, sir.
Yeah, good evening.
All right, thanks for the class. We really enjoyed it. Um, I want to ask this part of machine learning that we're going into now. Are we going to be using a predefined data set, or we'll use our let's say our own data set that we create and then train for the models, or what?
Okay. Yeah. The data set will be provided. That's not a problem. Like, we will be provided data set for what we are going to be doing. All right. You don't need to worry about getting data or all of that. We have everything ready. So once you get to that point, you're going to get it. All right.
So you made mention that we'll, we'll learn how to use most of this algorithm. My actual question, let me just take it straight. You said that we're not going to do deployment of the models.
Yeah.
Okay, no problem. Thank you, sir.
All right. Welcome. All right. Diane, ask your question, please. Unmute yourself. You unmute already. Just unmute yourself and ask your question. Hello. There's a noise at the background. Okay. Jack, please go ahead and unmute yourself and ask your question.
Good evening, sir. Thank you very much, sir. Sorry,
Uh,
sir. It's not really about the assignment. It's just that I'm new in data science, so I don't know this machine learning now. Because when we were reviewing the assignment, this correlation chart, in fact, I don't even understand it. I've never seen it before, so I don't know if it's going to affect machine learning, or do I have to go back and research more? I just want to know, please.
oh, you say you are new. Like, do you mean you just joined us?
No. I mean, I have never, like, the whole thing is new to me. I'm just learning from scratch. I started with the class. So it's whatever we learn in class that I know in data science.
Yeah, you need to understand correlation. We what I would just tell you just to go back to, I think, which of the class. There's a particular class on pandas, and where we talk about correlation, and we use heat map to visualize it. So you can ask your class rep. Just ask Mohammed. He will direct you um to that particular video, so you'd understand it better. It's necessary to understand this because you'll be using it in machine learning and all of that. So yeah, it's very important. All right. So is it Nachipita? Please ask your question or meet yourself and ask your question.
Okay, good evening, everyone.
Yeah, good
Thank
evening.
you for today's class. I really appreciate. So, I was the one that was ill and still getting better though. So,
Sorry about that.
um, okay, so I enjoyed today's class. I enjoyed everything. While you were going through the assignment, I also enjoyed it, though I couldn't turn in mine because of my ill health and all. But sir, I want to just want to or suggest or plea with the organizers or you, if another forum can be created for issues, because okay, while I was here I was trying to even get to you but I couldn't. The course rep I couldn't also because your accounts are private, so there's except my contact is saved, you saved my contact directly, I can't chat you, I can't reach you. And for these issues, I don't think there are things that you can go to the question section and just drop there. So that's why I'm just going to plea if it's possible, so that another um, how will I put it, forum or column is created for issues, so that when it's dropped there, you can see it, the course rep can see it, and any other person who can address the issues. Because sometimes when I
Okay.
also go through, sorry, when I also go through the classes, maybe to get better understanding, sometimes I want to ask some questions. So, but I just feel if I go to the ask questions, I don't get quick responses. So that's why I don't know if it's possible. Thank you.
Okay. Mute your mic. Um, okay, I actually don't know how, but I feel we have redundancy in the sense that there are eh, people send me DM, so I don't know why you can't, right? So you should check maybe from your end there's a restriction or whatever because other persons send DMs and all of that, and the class rep too. It should be accessible. You have the class rep, you have the assistant. All right. If you can reach the class rep, you reach the assistant. The assistant can reach the class rep, and the class rep can reach me. So I just believe there's enough that has been put into place to communicate or to make communication easy. All right. You have my email address. If you are unable to reach out to me here, you can as well send me an email. Some people send me email, all right, and I get them. So I honestly don't know how you have this difficulty reaching us, but I don't know if that is a general problem because people reach me regularly and I attend to issues, and the class rep does the same thing too. All right, so but I don't know if there's any specific problem that you might be facing that I don't know about, but that's just what I have to say about that. All right. The organizers too, they are accessible. You can reach out to Mr. Ebibuke or Pere, that is the admin. They are the career escort to general group. You can see them there. You just reach out to them. They will reply you. So I don't think there's any restriction that has been placed to make it difficult. the Q&A, I go there most of the time. The reason why I don't even answer questions most of the time is because people answer the questions already, and which I'm very happy about. Right? People answer each other questions. So if you maybe don't get your questions answered, you can tag me. Once I see you tag me and I see that the question has not been answered, I go to the Q&A and I see that it has not been answered, then I'm going to answer your questions. All right. So, and the class rep too also goes over those questions and all of that. So, I think you just try to utilize every means that you can to get better out of all of this. So, I think that should answer your question. All right. Last person, Marvelous, please ask your question. Marvelous Basti, unmute yourself, please, and ask your question. Marvelous, are you speaking? Someone said that mic is bad. Sadian, you have microphone issue. Oh, your question is in Q&A. Okay, let me see.
Please, sir, can you hear me now?
Yeah, I can hear you.
Okay, so mine is more not like a question per se. It's just that I wanted to know if it's possible for you to share like favors assignment question, because I know I missed some on my end, so I would actually love to like learn from her own if it's possible though. I couldn't really turn mine in because of some issues, but I know from seeing the assignment the way she did it, I know I missed a couple, so I would actually love to look at it and learn on my own if it's possible. And then I think Dane asked a question on the group. I think he said it's this thing, his mic is having issues,
Yeah, I've seen
and
the
he was
question.
asking. Okay, so that's just it from my end. Thank you.
Okay. Yeah, I'm going to share favors this on the material group chat, right? So the material resources, just check out for the file this night. So it's going to drop there. You can download it and go through it. Yeah. All right.
Right. Thank you, sir.
Okay, so Diane asked a question. He said that what was the question? Sorry, that is it that supervised learning. So is it safe to say that supervised learning has a more precise result than no, you don't they're not doing the same thing. They're doing different things, you understand? So you can't actually compare them in that aspect. They are doing different tasks, all right? So it's when maybe they are doing the same task that you can now compare them. So unsupervised learning is doing a separate thing. So there are problems that only supervised learning can solve. And there are problems that supervised learning is the best for. All right. So that is just how you have it. You don't compare the both of them. All right. So thank you very much for your time and your attention. This was a very interesting session from the question and answer to the assignment to the machine learning introduction, all of that. It's actually quite interesting and exciting. Having this class with you. I love the proactiveness and I love how we are eager to participate and learn. So just keep it up, and we're going to see tomorrow again. Your assignment will be graded hopefully tomorrow, if not Monday. A law is on my table. I'll try to do that. And yeah, so have a nice day, and please drop what you've learned today. I believe you learned a lot, so don't fail to drop in the group chat what you've learned today. Please try to do that. Thank you very much and enjoy the rest of your day.